Okie doke. So we're on to 5.4. We're going to look at multiplying polynomials today. So we've been working our way through the different operations with polynomials. So now today is the day to talk about how do we multiply, which basically is just looking at doing a lot of distributive property and making sure we know our rules for exponents and being able to put those together. So we're going to jump right in. A lot of this will be review, but again, it's trying to hit on some of those big ideas that people sometimes struggle with. So we're going to start with monomials. Remember, mono means one, so single terms. Basically, all this means is we're just going to multiply two things together, and we have to deal with numbers and we have to deal with variables. So we're going to do both of them. So if we notice, we have a monomial here and a monomial there with parentheses. That always means multiplication. So we're going to multiply those together. A good way to think of this, kind of reorganize, is think about we're going to multiply the coefficients together. And then I'm going to do a little sorting and organizing. So I'm going to multiply together the k's. So a k to the third times a k. And remember, it's just k, that's always raised to what power? That would be to the first, so k to the first. And then I'm going to multiply the y's. So I have a y times y cubed. So again, a y to the first, right? If it's not written, it's a 1, and a y cubed. Now, the work that I just showed is what a lot of people do in their head. So it's kind of they're sorting and organizing in their head. You don't necessarily have to write it down, but that's really how we want to think about it when we multiply monomials together. So we're going to multiply those coefficients, the number part. So 8 times 9, that's just 72. And then let's do our k's. Remember the rule for multiplying with the same base. What do? Add the exponents. That would be k to the 3 plus 1 or 4th power. K to the third, 3k's plus another one. All right, and then y, same thing. 1 plus 3 would be y to the 4th power. So 72k to the 4th, y to the 4th would be multiplying, or the product of these two monomials. So if you can think about that organization, coefficients together and put like variables together when you multiply, it does make it a lot easier to do that multiplication. All right, how about a monomial times, how many terms are on the inside here? Separated by that subtraction, 2. What do we call those two-term things? Binomial. So it means distributive property. So we're going to just multiply this negative 2r times everything on the inside. So negative 2r times 9r. So that multiplication. And then we're going to do negative 2r times a negative 5. So negative 2r times a negative 5, or a minus 5. Now, again, a lot of people don't show the work that I just did, but that's what you're doing. You're distributing or multiplying this negative 2r times both of the terms on the inside. And again, sorting and organizing, let's multiply the coefficients together, the number part. So negative 2 times 9 would be negative 18. R to the first times r to the first would be r to the second power. So r to the second. And then our second term, careful on this one, a minus times a minus would be a plus. 2 times 5, that gives us 10, and then r. Now take a look, those two terms are not alike. Remember, they have to have the same variable with the same power. They don't. Same letter, but not same power, so this is as far as we can go. Multiplying by a monomial just means, hey, distribute it through to everything on the inside. So it's very similar to what we've talked about before. We've done this before. All right, now let's take a look at what we're multiplying here. We've got two terms in each, so a binomial times another binomial. So these are both binomials. Do you remember how to multiply two binomials together? There's a helpful word that we sometimes remember, kind of a mnemonic device, the acronym FOIL. Remember what FOIL stands for? So first, and then outsides, and insides, and last. So it's a way to help you remember what you need to multiply together. It's like the double distributive property. So imagine that we are multiplying everything in the second set of binomials by this 2k. So like ignoring like this 5m was even there. So we're going to do 2k times the 3k. That's the first. And then we're going to do 2k times the 2m. That's the outside. So the things are on the outsides in the binomial. So it's almost like you're covering up that 5m, and we're not even worrying about it when we do that first multiplication. So I'm going to go ahead and do that, the first and the outsides. I'm going to try to keep the color coding here as well. So first and outsides we'll do in blue here. So we're going to do 2k times 3k. That's first. And then outsides would be positive times a positive, so plus 2k times 2m. Now, a lot of people don't show the work that I just did. They just actually multiply those together. So 2 times 3 would be 6. K times k is going to be a k to the 1 plus 1. second. And then we have a 2 times 2, so 4. Now this is just 2 letters, a K and an M. When there's 2 letters like that, a lot of people just go alphabetically just to keep organized. So that's the product of the first and the outsides. That's distributing with the 2K. Now we're going to do the same exact thing, but we're going to distribute with the negative 5M. So we're going to do negative 5M times the 3K and negative 5M times the 2M. That's the inside product, right? And then the things are in the last position. So we're going to be multiplying. So next would be negative 5M times 3K, and then negative 5M times 2M. And again, if you don't want to show that work, that's okay. We can just do that multiplication. So the negative 5 times the 3 would be negative 15. And again, we have an M times a K. So M times K, can't really do anything with that. They're not like bases, but I'm going to write them in the same order I did the last time, alphabetically. It helps people put their like terms together. And then we have a negative 5 times a 2, so a minus 10. And then M times M to the first, M to the first would be M to the second. So when you do double distributive property here, or the FOIL, as like a lot of people will say, we end up with 4 terms. Now, whether or not you can put things together, it depends on if there's like terms or not. I don't think there's any other K squared terms, so 6K squared is kind of going to stand alone. But take a look at these middle two. Often this will happen. Those both have the same variables, km to the first, so we can put them together. So 4 minus 15 would put you at negative 11, and that would be km. That's, you have negative 11 of that term, and then minus the 10m squared. So when you're doing a binomial times a binomial, just think FOIL, first, outside, inside, last. It's double distributive property. You're distributing with the 5m, and you're distributing with the 2k, everything in that second set of parentheses, and we can put together like terms. Now, just as another option, this is kind of interesting, just like we did with adding and subtracting, you can multiply using kind of a vertical perspective. I'm not sure if that's helpful or not. I'll kind of illustrate what that looks like, and you can decide if that's a better way for you to do it. This problem is exactly the same as what we just did. If you wrote it horizontally, it would be 4x minus 3y times 3x minus y, and you could just go ahead and do FOIL. We're still, by the way, going to do FOIL, but we're just going to do it vertically. It's sort of the difference between I'm going to multiply like 10 times 30 horizontally versus I'm going to multiply 10 times 30 horizontally. It's the same conversation. So let's try this and just see how that would work. So normally when we multiply, we start with the product here, and we multiply the y times the 3y. So we can do that multiplication and see what we get. And then we can do the y times the 4x and see what we get there. So I'm going to go ahead and do that. So a negative y times a negative 3y, so negative times a negative would be a positive 3, and that would be y to the 1 plus 1, y to the second. So that would be that first product. Okay, now I'm going to multiply this negative y times the 4x. I'm just following regular multiplication rules here. Negative times a positive would be negative, and then we have a 4, can't really do much with the xy. Now again, we got to be careful, what sign should I put between those two terms? Well, this was a positive 3y squared, so that's going to be a plus. So it's just regular multiplication here. So we just distributed, we just multiplied basically the equivalent of that negative y times both of the first things. All right, now I'm going to use different colors. Now we're going to start with the 3x and do the same thing. We're going to do this product. So 3x times negative 3y. So a positive times a negative would be a negative, so negative 9. And it's an x times a y. So I'm going to go ahead and line it up right underneath the other term that is also, right, same place value. It's just like normal multiplication. You'd line up those place values. And then the next product I would do, the last product actually, is this. So 4x times 3x. So 4 times 3 would be 12. And then we have x times x, which is x squared. Okay, now remember what you do when you do regular multiplication. We did this earlier in the year. We add those two rows together. Sometimes people put that placeholder there just to help kind of line things up. So I'm going to go straight down here. So I have a 12x squared. I have a negative 4 and a negative 9, which puts me at negative 13 xy, and then 3y squared plus 0 would be plus 3y squared. That's another option, right? I would get the exact same answer as this if I had just done FOIL on this original. Some people like to think vertically, some people like to think horizontally. I guess whichever way works better for you, that's what you should try and follow if that works a little bit easier. Now I'm going to take a look at this next one here. This is a binomial times how many terms do we have here? 1, 2, 3, 4. Now, if you're going to do this horizontally, this would mean 2a minus 5 times this whole big thing. So 5a cubed minus 6a squared plus 2a minus 3. Okay, so if you're going to do this horizontally, you would be distributing the 2a times all 4 of those terms, and you would be distributing the 5, that minus 5, times all 4 of those terms. So we have that as an option as well. So I'm going to do this one vertically, and then you can see how you like that, and then I'll contrast that with doing the horizontally, and you can see which multiplication works better for you. All right, so let's start with, we'll start with the 5, I guess. So let's do, yeah, because we got to start with that first place value. So negative 5 times negative 3 would be positive 15. So I'm just going to go ahead and say plus 15. Okay, then we're going to multiply negative 5 times 2a. So positive times a negative would be negative 10a. And then we're going to multiply the negative 5 times the negative 6a squared, trying to keep the product here. So negative, negative, which should be a 30, and then a squared. And then our last one, we're going to multiply the negative 5 times the 5a cubed. So 5 times 5, 25, and that would be a to the third. So for that one actually works pretty well. Now we're going to do the same multiplication, but with the 2a. So we're going to do 2a times negative 3 first. So positive times a negative would be negative, and then 6a. Notice where I put it. Same thing you would do with regular multiplication under the same place value. So we're keeping that place value together. That means we're keeping our like terms together. People like vertically because of that, right? It's easier to put your like terms together at the end. All right, now we're going to do 2a times 2a. So that would be plus 4a squared. A to the first would be a to the second. All right, then we're going to multiply 2a times a negative 6a squared. So positive times a negative should be negative, and then 12. And then we have an a squared times an a to the first. Add the exponents, that would be an a to the third. And then our last multiplication for this one, for the 2a, we're going to multiply it by the 3a to the third. So 5 times 2, that would be 10. And then a to the third times a to the first would be a to the fourth. All right, so just like in the last one, when we do multiplication vertically like this, we add these like terms together, and we just go each place value. So 15, and again, if you wanted your placeholder here, that would be positive 15. Negative 10, negative 6 would be negative 16a. 30 plus 4, still 34a squared. Notice it's positive. 25 minus 12, think on that for a second. That would be 13a to the third, positive, right? And then we have our 10a to the fourth that there was no like term with. So we have our polynomial answer. It ended up to be 5 terms. So that's the vertical representation. That may work well for you. If you like having those place values lined up, it makes it a little bit easier to keep track of your All right, I wanted to show you the other option that I talked about, going horizontally for your multiplication. So distributing with the 2a first, I distributed 2a times each of the terms in that second set of parentheses. So I had those first 4. And then I did the same thing with the negative 5. I distributed to all 4 of those terms and got these 4. Now what you'll notice if you look back to your vertical work, these are the exact same terms that we had. Look at the green and match up with the green up here. Look at the red and match up with the red up here. They're exactly the same. It's just horizontal instead of vertical. So it's sort of a preference thing, but now when we put our like terms together, you have to do some hunting. So it looks like there's only one a to the fourth term, right? And then we're going to put together our 2a cubed. So you have to find those, right, to be able to see where those are. So we want to make sure that we're okay with that. Alrighty, so I just noticed a little goof that I made with my sign down here. So I know I have the sign correct down here. I forgot my minus 25. So sorry when I did this product, negative 5 times. This is why we got to always go back and check our work. So it happens to me too. That should have been a negative 25. So that means when we put our like terms together here, this should give us a negative 37. Super sorry about that, but glad we went back and checked it the other way, right? Negative 25 and a negative 12, which should match up exactly with these. So glad I did it the other way as well. So see how easy it is to make an arithmetic error when we're walking through things. So when I put those two together, that would be negative 37a cubed. There we go. And then we have our a squared, so plus 34a squared. And then we have our minus 6a and minus 10a, so minus 16a, and then our plus 15. So either way, horizontally or vertically for multiplication, we should end up with the same answer. Sorry about the arithmetic goof there. Some of you are probably like, what is she doing? But it works out the same either way, whichever way is easier for you to do. All right, we're going to talk about some more special cases, multiplying differences of two terms or like squaring a binomial. What does that look like? So let's talk about what's going on with this one. How many things are you multiplying together in example 4? How many things do you have? Well, you have a monomial, and then you have a binomial, and you have another binomial. So we have 3 things to multiply together. So we have to just start with 2 of them, pick 2 of them to multiply together, and then get your answer, and then multiply by the 3rd one. Now, one thing I want to focus on in this one is what happens when you multiply 2 binomials together like this. So I'm going to start with those 2 and see what happens. Now, I want you to notice if you compare those 2 binomials, what do you notice? Well, they have exactly the same letters and numbers, but one's a plus and one's a minus. So it's called difference of squares. I want to see what happens when we multiply those together. So we're going to start with those products and then see what happens when we do that product. So I'm just going to leave this 4y squared out front for the moment, and I'm going to go ahead and do FOIL with those 2 binomials. So y times y gives me y squared. Y times a negative 7 would be negative 7y. 7 times y would be a plus 7y. And then we have a positive 7 times a negative 7. So be careful on the sign there. That would be negative 49, multiplication. All right, now notice what happens when we can put our like terms together. Look at those inside and outside. Your oy adds to what? 0. That's completely gone. So all you have left is y squared minus 49. With this 4y squared still out front, right? That's just a kind of that monomial out front. But notice what happened when you multiply 2 binomials together that have the same terms, just opposite signs. It's called difference of squares because you end up with 2 perfect squares and a difference between them because you did a positive times a negative. So you'll always see that when you have those. So if you start to recognize that, you can save yourself some work over here. If you know those inside and outside terms are going to add to 0, we can just know that it's going to be those first and last. Now, to finish this one up, we do still need to distribute through that leading coefficient term, that 4y squared. So we're going to go ahead and do that. So 4y squared times y squared would be 4y to the what? 2 of them, 2 more of them would be y to the 4th. And then we've got 4 times 49, so I need to multiply those 2 together. And it's a positive times a negative, so go ahead and type that in. So 4 times 49, 196, and then y squared. An easy way to do 4 times 49 in your head, do 4 times 50, which is 200, and then just take off the 1 for each of the 49s, and then you get to 196 if you're doing it in your head. All right, hopefully you have a calculator though too. All right, let's talk about squaring a binomial. Similar to what we just talked about, but a little bit different. What does it mean to square something? Well, you multiply it by itself, right? So if I say to you 3 squared, you know that that means 3 times 3. You're multiplying that base, whatever it is, times itself. 2 times. All right, so what would 3k minus 2n squared mean? Well, that means you're taking this 3k minus 2n and you're timesing it by itself. The biggest issue that people have with this is they just think, oh, I just square everything on the inside. Well, see, there's a subtraction there. So that means this whole thing is the term that I'm squaring. The whole 3k minus 2n needs to be multiplied by itself. So it means FOIL. When you square a binomial, that means FOIL. You have to do first, outside, inside, last. So we're just going to do our regular distributive property here. So 3k times 3k. So 3 times 3. Go ahead and pause the video. See if you can FOIL this one and then come back and check the answer since we've been doing several FOIL now. So see if you can come back with the correct answer here on this one when you multiply and check back in. All right, so that would be 9k to the second. Outsides, you do 3 times negative 2, so negative 6. And then here we have this issue with 2 letters again. I would just go ahead and write it alphabetically. For me, that's the easiest. All right, then the next up, we're going to distribute with the negative 2n. So I'm going to multiply those together. So again, we have a 2 times a 3, so negative 6. And then I'm going to, again, write it in the same order. So k times n makes it a little bit easier. And then last, negative times a negative, careful on that, plus 2 times 2 is 4. N to the first times n to the first, n to the second. All right, now is there anything that we can put together as far as like terms go? Both of these insides. Unlike the last one, though, where they added to 0, for these, when you square a binomial, these terms will always be exactly the same. So it's like double. You have 2 of them. So we have a negative 6, another negative 6, which would be a negative 12, kn, and then plus 4n squared. So when you square a binomial, just don't forget, that means you're multiplying it times itself. That's what squaring means. So you do have to do FOIL there. So we want to make sure that we get all of those terms. All right, so we can multiply binomials together. There's some interesting things that happen with those signs. All right. Now let's talk about how do we do this in function world, function land. So instead of just saying, here's my polynomial, what if they give it to you in function notation? So they're saying, hey, f of x is this, and g of x is this. So remember, g of x is just a fancy way of saying output. The y equals f of x, same thing. It's just like the output. So what does this mean then? Let's talk about what this is saying. F, and then right next to a g, like no symbol in between. Well, when you see like a letter next to a number or 2 letters next to each other, what does that normally mean? Well, that's multiplication. So what this is saying, this name of the function right here, that's telling you to multiply. So the name is saying, hey, take the function f and you're going to times it times the function g. This is multiplication. So if you see anything like that, that just means multiply. And then you're going to evaluate that product at 2. So we're going to multiply them together, and then we're going to evaluate that product at 2. So we want to see what that looks like to be able to solve. So I'm going to, oops, and then this one, I've got to go back up to this one too. We're going to multiply them together, and we're just going to give the rule just with x. So we're going to do both. So we're going to find actually just the rule first, and then we're going to figure out what it would be actually at 2. So we're going to do both. But when you see 2 letters right next to each other, that means times. All right, so f times g of x. Remember, that just, again, means multiplication. Means, hey, I'm going to take the 3x plus 1, which is my f of x, and I'm going to multiply it times my 2x minus 5, which is the g of x. So that's all it means. It's the same question as what we were doing before, and we just do FOIL because it's 2 binomials. So let's go ahead and figure out what that would be. Go ahead and pause the video, do your multiplication, do FOIL, and then check back in. So 2 times 3, that would be 6, and then x to the second. Outsides, 3 times 5 would be 15, and then x. And notice it's a negative, right, because we're multiplying a positive times a negative. And then insides and last, so we'd have a plus 2x and then a minus 5. So we'll go ahead and put our like terms together, these middle two. So we have 6x squared minus 13x minus 5. That would be f times g of x. Okay, so we have the rule. We could generate whatever we wanted to then. We just multiplied them together. All right, so what does f times g of 2 mean then? So we talked about this at the beginning. That just means, hey, evaluate this product, this function, at 2. Replace the x with 2. So they're saying, hey, x equals 2. What's your output then? So we're just going to put in that 2 and simplify. So go ahead, take a moment, type it into your calculator, do your arithmetic here and see what you get. All right, so 2 squared is 4, times 6 would be 24, 13 times 2 is 26, subtract across, negative 2 minus 5 more, looks like we're at negative 7. So f times g of 2 at that particular number is negative 7. I could put in any x value into that rule now that I wanted to. Another approach to doing this question, the second part, if all you wanted was just this, you could, this is an alternative, if all you're looking for is this number, you don't want this rule, so you could generate other ones, that also means, hey, I'm going to do f of 2 times g of 2. Just like I could have back here, if I'm talking about this rule, f times g of x, what that means is f of x times g of x. Just like that operations we did with adding and subtracting. When I multiply those, when I see what that means, it just says, hey, multiply f of x times g of x. That's what that symbol means. So if I'm evaluating it at a particular number, that just means f of 2 times g of 2. And I could do it that way as well. So I could put this 2 in for the x in the f function. So 3 times 2 plus 1 times, and I could put this 2 in for the x and the g of x as well. So that would be 2 times 2 minus 5, and I can multiply those together. So 6 plus 1, that looks like 7 times 4 minus 5, negative 1, and sure enough, I get the exact same answer. So you can just do it directly if all you're trying to do is the numerical one. I wanted the rule as well. It said I wanted f times g of x, so I did the rule, but you can also just evaluate each of those functions and then do the operation together. F times g, that's what that means. So function notation is another way we can express products. All right, so let's get into an example of where you can actually use some formulas and that have multiplication of binomials, trinomials, whatever it might be. So this is an example that's going to illustrate that. So say you want to calculate the area of this triangle. By the way, formulas, if you need formulas for things, they're listed in your textbook cover. There's a bunch of them in there. So if you look in your textbook cover, you'll be able to find a bunch of them. So we want to find the area. Notice there's expressions on the side here that aren't just numerical. We need to know the formula for area of a triangle though. So can you look that up? Can you, or if you remember it, area formula for a triangle. Either look in the front cover of your textbook, you can Google it, whatever you need to do. Come up with that formula. What's the area formula for a triangle? All right, so hopefully you did. Pause the video if you didn't, go find it. 1/2 base times height. All right, so base and height are the two dimensions of that triangle. So the base and the height. In this case, it's a right triangle. So we have our height here, and then we have our base here, the way it's drawn anyway. So 1/2 base times height. So when I take a look at writing this formula then, I'm going to do 1/2, and I'm going to multiply my base expression, 3x plus 2y, times my height, which is 3x minus 2y. Now, remember when we had three things to multiply together, if I want to simplify this, I would start by multiplying those binomials together. And if you notice, again, look at these two binomials, they're exactly the same except for what? One has a plus, one has a minus. Some good things are going to happen with this one. Some terms are going to add to 0. So let's go ahead and do that multiplication. So 3x times 3x would be 9x squared. Don't forget to multiply the coefficients. Outsides, negative, okay, we got 3 times 2, so 6. We've got an x and a y, so 6xy. Then we'll switch over to our 2y times 3x. That would be a plus 6. And again, with the two different letters, put them alphabetically again so we can sort and organize easier. That really helps. Plus 2 minus 2 would be a minus 4. Y times y would be a y to the second. And remember, all of this is still multiplied by this 1/2 out front. Okie doke. Now take a look on the inside. We have some like terms. When you have these opposite signs, this will always happen. Those two inside and outside terms, they add to 0. So all you have left is 9x squared minus 4y squared. It's called difference of squares. And then we have that 1/2 out front. Now, depending on what you want to do with this, you may want to just leave the 1/2 if that's going to be a situation where you have numbers that are maybe not as nice to deal with. So if that's something that you don't want to have to worry about, that's totally fine. If you want to distribute it through though, you could certainly do that as well. So you could multiply through and make sure that you have just two terms with that coefficient. So you could say 1/2 times 9, so 9/2 x squared, and then half of 4, that's a little bit better, 2y squared, makes it a little bit easier to see. So if that's something that is easier, those would be kind of an either or though, I guess, how you wanted to see those values. So multiplication of being able to do binomials, trinomials, whatever it is, will definitely come up in lots of different algebraic settings, and we just need to be comfortable and confident dealing with those.